Hi, everybody. Welcome to my History of Tracing Oracle. I'm Cary Millsap. It's a real honor to be on the P99 conference agenda. I've looked forward to this for a long time, and hopefully we're going to have some fun today. By way of introduction, I am Cary Millsap. I'm the founder and president of a little company called Method R Corporation, which has been around for a couple of decades now. I personally have been an Oracle performance specialist since 1990. When I left there in 1999, I'd kind of climbed my way up to being the vice president of an 85-person consulting group in the late 90s. In 1999, I left Oracle to become an entrepreneur, and it'll become obvious through the material, the kind of things that I've done for a living for the past few years. I'm the author of a few books. The most recent one is an O'Reilly book published just this year, a few months ago, called How to Make Things Faster. It's not about Oracle specifically. Of course, some of the stories come from my Oracle experiences, but it's not a strictly Oracle book. Have written plenty of Oracle specific books. On the last page, I'll show you a picture of the covers if you're interested in those. On a personal note, I'm a faithful husband and father of a brand new attorney. My eldest son just got his license a couple of days ago after a long experience through law school and taking the bar. My middle child, he's not a child anymore. He's a pitcher in the NCAA. And my daughter is a senior in high school, and she's the captain of her Class 6A high school volleyball team. So I'm very proud of them, and that's what I'm really doing this for. And then finally, interesting note to me and my nerd friends, I make award-winning museum-quality aviation replicas. That basically means model airplanes as an adult. And recently, about 3 weeks ago, I won my class, which puts me in the top 8 of over 3,000 entries at a national competition that was held in South Texas a couple of weeks ago. So that's what I do when I'm not doing this kind of thing. So let's just jump right in and talk about Oracle tracing. And the first question that needs to be answered is, what is it? And it's a lot of things. It's Oracle's telemetry feature that comes with the database product at no extra charge. It's part of all the editions of Oracle, but it's limited in Oracle's autonomous editions. And Oracle's still kind of fighting with this identity of how self-tuning is autonomous, because one of the things that happens when you say, well, it's self-tuning, why would we need a telemetry feature? Well, the people that need to make that need to maintain the database product itself need telemetry features, and also application developers who are writing code that runs with Oracle need telemetry features as well. So Oracle's kind of struggling with, we don't want to give people too much information to make our product look complicated. And then on the other side of the coin, there is, but we do need telemetry, because even if your system's self-tuning, it needs to be observable. The way that it works, this tracing feature of Oracle's, is that server processes write calls to a file. So it's similar, these calls are similar to what in the open telemetry specification you would see called a span. There are some really cool, like magical procedures to enable and disable trace, and we'll talk about those in a few slides from now. The thing that everybody always wants to know whenever we start a conversation about tracing is, yeah, we thought of tracing at one point in our history, but we all decided that we're too afraid of the measurement intrusion effect that it might inflict upon our application, and therefore we're not going to do it. So I've got a couple words I'll say about that in due course as well. But it's basically, tracing is imperceptible as a measurement intrusion if you do it right. Now, Oracle does make some tools to deal with trace data, but they're very rudimentary. And as I'll show you in a few pages, they're really not good enough to do much, to be frank. But we have a solution for that. So this is what trace data looks like. I think I'm going to leave this slide up for about 17 minutes. I think that's how much time I have left. Let you fully regard it, fully read it, parse it mentally, or maybe we shouldn't do that at all, because nobody in his right mind would want to look at data like this without tools. So Oracle traces are different from any other Oracle performance data in several ways. Number one, traces are unfiltered and unaggregated. And these two properties make it to me, it makes it the primary data source for performance types of questions. And I'll explain more about that as we traverse the pages here. Other Oracle data sources come pre-filtered and pre-aggregated. And I'll show you on the next page why that's bad. Basically, it limits the questions you can answer. And there's a really good page about this in Charity Majors and her co-author's book called Observability Engineering, also an O'Reilly publication. And on this page, it's page 5, and it's just full of gold nuggets. But two of the sentences here on this page are, can you understand what any particular user of your software may be experiencing at any given time? And with trace data, the answer to that is yes. With other data that's pre-filtered and pre-aggregated, the answer to that is no. But even more importantly, the second sentence here, can you answer questions like the preceding ones, like the one I've shown above, without first needing to predict that you might ask them someday, and therefore set up specific monitors in advance to aggregate the necessary data? So basically what Charity and her co-authors are advocating here is a definition of observability that means I don't care what the question is, I shouldn't have to do extra stuff to be able to answer the question. And trace data actually gives us the ability, because it comes unfiltered and unaggregated, we can filter and aggregate traces any way we want. And this means that you'll be able to answer questions that you never expected to get. So let's talk about tools for a moment, because I showed that just reprehensibly ugly purple slide with all this stuff on it, which is an Oracle trace. But as with any telemetry data, as with any data that you have that much of, you need tools. And the tools really need 3 operations of capability. Number 1, they need to enable you to filter the data. Number 2, they need to enable you to group the data. And number 3, they need to enable you to sort the data. I'll tell you a story to kind of reinforce what I mean by filter, group, and sort when it comes to talking about trace data. So the story I'm going to tell you is a very, very condensed story of a true story about an airport operating system in which the airport was having an application time out about 10 times per hour over the course of roughly 100,000 transactions. Now that's a lot of 9s. I forget whether it's 4 or 5, but it sounds like a really good success rate to only have 10 timeouts in 100,000 transactions. But the problem is every one of those 10 timeouts requires an agent of the airport to actually come and have a conversation with somebody that's really frustrated. So what we want to see in a group of trace data in the story I'm going to tell is the 10 worst response times grouped by user experience. And then once we know what those are, we're going to drill in on a specific user experience grouped by call name. And I'll show you that in just 2 slides here. Here's the first one. So again, the story is we've got we've got an average of 10 timeouts. When the airport collected the trace data, there ended up being only 5 timeouts, which if you think about it is the perfect number of timeouts to have in a situation like that. Pretty much the worst thing that could happen is we convince the airport to enable tracing. They agree reluctantly, but they agree. And then when they trace, nothing times out. That would be horrible, right? Because now we've gone to all the effort of catching data, but we didn't catch any application timeouts in the act of misbehaving. So we'd have to do it again. Now, maybe a worse thing, not worse than that, but maybe the next worst thing would be that we trace, and instead of having 10 timeouts in an hour, we have 50 timeouts that hour. And that would probably cause people to engage their immune system about tracing and say, no, I traced one time and it made things a whole lot worse. So this is actually sweet spot what happened. We asked them to trace, they traced for an hour, they had 5 timeouts. That's way better than 0, and it's way better than 10. And I'll stop blabbing now and start pointing. These were the timeouts. There was one essentially application function whose trace shows up in a file called gxlAura_131168.trc. And beginning on line 145,010, there was a 9.5 second, 9.447 second experience that somebody felt. And in another file, there was another experience that somebody felt. And there are 5 of these that are bigger than or equal to 5.0 seconds. And those are precisely the 5 timeouts that the airport experienced while they traced. So the thing I want to see next, so let me, before I change the page though, I want to recap really quickly. So what we've done is we've taken all the trace data generated in an hour and we have grouped it by user experience. And then we've sorted those experiences in descending order. So the filter was we traced for an hour. The group was we want to show the experiences that people felt. And then the sorting order is I want to see the worst at the top. So now that we've seen the worst at the top, what I want to do is drill in and focus on this 9.447 second experience. And with the right tools, we can take the same exact trace data and we can create what I call a profile by call. Now, some of these, if you're familiar with Oracle, are so-called wait events, which really are system calls in the Oracle universe. So this is a system call. It happened one time and it took 8 seconds. And this happens to be a row level lock. So that explains why our worst timeout occurred. The next thing on the list is a single call of a log file sync, and that's an internal thing that Oracle does to keep its log files up to date. And you can basically see everything that happened during that 9.44 seconds just by grouping a little differently and filtering the data. So now we're only looking at this 9.44 seconds. That's our filter. Our group now is grouped by call name, and that's what you see in the first column here. So that's what I mean when I say that we want to be able to filter, group, and sort the data any way we want. And trace data, not just Oracle trace data, but any trace data should make those operations easy to do. So here we go. The problem, though, is that Oracle does not have tools for doing that. Now, it sounds bizarre, but they've just invested in other types of philosophies of application performance data. So Oracle's tools, while they have tools that deal with trace data, they're very rudimentary. And the ones I'm talking about are primarily their best ones, TK-Prof, TRC-SES, and a thing called Trace Analyzer, which is kind of a web-based version of TK-Prof. So there aren't really a lot of after-collection filter options that Oracle offers because TK-Prof doesn't do it. TRC-SES will enable you to say, I'd only like to see things for that session ID or for that certain attribute that an application developer can set. But there aren't a lot of after collection filter options that Oracle gives you. And there's really no grouping flexibility either. You get things grouped this way, period. DB call by SQL statement and system call by SQL statement, and that's it. TK-Prof is responsible for that stuff, and those are the only options TK-Prof gives you, is to group by DB call by SQL statement or syscall by SQL statement. That's it. So this is one of the gaps. I told you I left Oracle in 1999 to found a company, and this is one of the gaps that I've been working all this time to help fill. So we do have tools that fill these gaps in, but Oracle doesn't offer any. So one thing that Oracle does exceptionally well, though, is their tools to enable and disable traces. And those end up being the best filters that Oracle gives us. So you can enable or disable tracing several ways. Number one, you can do it in your code path directly. So if you're using SQL Plus or SQL CL, a command line interface through the SQL language to the database, you can say things like, run my BigQuery on line 2, but on line 1, you can say enable tracing. On lines 2 through 1,000, there's your BigQuery. And on line 1001, there's your disable tracing. And probably a query to find your trace file name and some cleanup types of things like that. So you can drop, enable, and disable in to bracket the code that you're running if you have access to your source code. If you happen to have an in-flight session that you want to trace and you know it's Oracle session ID, you can specify with a standard package that Oracle ships that I would like to trace that session whose session ID is 1234, for example. The next one is really the magic one. You can trace sessions that identify themselves a certain way. Now, for this to work, and I've got a little footnote here in a second, you've got to do something special. So let me get the next point out of the way, and then I'll come back to that. You can also, if you have no better way to filter, like the airport didn't, then you can trace a whole instance. So the airport had to trace a whole instance because the answers to questions I asked, like, is it always a certain user? Is it always a certain application that times out? Is it always a certain anything? Is there any kind of handle that you can give me that says we only see timeouts when this thing's running? And their answer to that was no. We see timeouts almost at random, generated for every user of our app in all the features of the app. So really, without any filtration devices, we were grateful that you can trace a whole instance. It normally scares people when you talk about tracing a whole instance, but we have actually measured very carefully with other vendors' tools what the impact of tracing is. And as I said, it's negligible if you do it right. So I mentioned a moment ago that these tools are brilliant, but that one that talks about identifying a session a certain way, that requires foresight and cooperation with the application developers. It's really easy in Oracle to sort of earmark certain functions of an application by name. So for example, if you're writing an ERP application that does month-end close processing, so you've got a program that posts, another program that imports, another program that allocates. Well, if you call those programs posting, import, and allocation, then you can actually set up a standing trace order that says, hey, any program that runs that identifies itself as posting, I want that traced. It's a really cool feature. So you can basically at 3 o'clock in the afternoon say, yeah, we're going to post tonight around 2 a.m., but I don't have to be here for it because I'm going to type a command that says, whenever any program identifies itself as general ledger posting, it will automatically be traced. It's absolutely brilliant. It's kind of magic. It has to be built into the kernel of the database in order to do something like that. But it's a really, really cool Oracle feature. So that brings us naturally to, well, what does Oracle get right about this tracing business? And it gets a lot right, frankly. Number one, the very notion of tracing every database call and every system call, you don't get that with any other database that I know of, certainly not the NoSQL types of things. SQL Server, is the first question that people ask me when they find out that I'm an Oracle performance expert is, oh, wow, we really need that for our SQL Server database as well. And I think the information may be possible to extract, but there's no thing like Oracle has that will actually list, as far as I know, in Postgres or MySQL or SQL Server that will list the amount of detail that Oracle will. So it's something that they got tight and right. It's a useful data format. It's not a perfect data format. It really is a data format that's kind of evolved over the decades instead of really having been designed by a master designer. So it's sort of, as a design, it's sort of accreted over the decades, but it's good enough. It's good enough to be exceptionally useful. And Oracle also has a track record of improving the tracing feature. I kind of groused a little while ago about Autonomous kind of can't decide how much tracing feature to put into the product, but over the years, every 5 or 10 years or so, Oracle will make these like magnum leaps forward in tracing technology. And it's fantastic what it's been trained to do over the last couple of decades. There are also smart ways of enabling and disabling trace, as I mentioned a little while ago, and especially these procedures to create standing orders. And for those of you who are in the Oracle universe, you'll recognize the package names DBMS Monitor, and there's a thing called DB enabled traces, where you can actually consult a table to see what traces do I have in standing order mode at this point. They also have a really cool levels system. So you can actually alter the amount of detail that you print into the trace stream by setting various parameters on the trace itself. So you can do really lightweight traces or you can do heavier weight traces with these levels. And that's nice because the lighter weight ones have less measurement intrusion effect. The heavier ones have the potential to have measurement intrusion effect, but you can actually avoid that if you make sure certain things are true before you try to use those heavier tracing levels. One of the really nice unexpected things that Oracle does with its trace data is it captures interactions with non-database tiers. So you can solve problems that you may not have expected that you would be able to solve. Like, for example, client programming anti-patterns, like chatty apps that push one row at a time across the network, that do unnecessary database calls inside of loops, things like that. Hardware problems like disk or network latency issues show up vividly in trace data. Load problems like CPU starvation and SAN oversubscription show up if you know how to look for them in the trace. And there's a story. If I'm going to tell you that something is unexpected, I owe you a story to prove it. So this is a story of a company that had an overnight batch processing job that had to finish by 8 in the morning in order for their customers to use the results of the nightly batch. And when it doesn't finish by 8, they actually owe their customers penalties in cash. So they were strongly motivated to make sure that this nightly batch fit in its window, but it was leaking out into 9:30, 10 o'clock in the morning. So it was taking too long, but we have tools that take trace data and export to CSV the attributes of the trace file name, the beginning time of that file's first operation, and the ending time of that file's final operation. And when you have all that, it's easy to make a Gantt chart in Microsoft Excel from the information that looks like this. And when you see this, one of the things that ought to occur to you is, okay, here's stuff that's taking place inside the database, but what in the world is going on right here? The database isn't really doing anything, yet everybody was blaming the database for the nightly batch taking too long. Well, just by hovering in Excel, you can actually see the name of the file that that little bar represents. You can look in the file and see what the last SQL statement to be processed was. So now you know the last thing that happened inside Oracle before the gap. And if you hover on the chip after the gap, you can see its file name, and you can look in that file for the first SQL that shows up in there. So now we know between this SQL statement and this SQL statement, the application did something that took a long time. Well, by being able to identify that to the application administrator, the final SQL before the gap and the first SQL after the gap, the application administrator knew immediately. I mean, it was on the same phone call. He's like, oh, I know exactly what's doing that. And he told us, he said, yeah, that was number 17 on my list of things to try. But now that I know that that is the bottleneck to our nightly batch job, he went off and solved it in a matter of 2 hours. He had saved, I think, 2 or 3 hours from the nightly batch duration just by catching those things in the app. So they really had a problem that had nothing to do with the Oracle database per se, but the Oracle database trace data led them to solve the problem very quickly. So we're almost done. Why isn't Oracle tracing more popular? Well, they've never advocated tracing as a primary data source. You might think it's because their tools aren't very good, but they've had the opportunity to build whatever tools they wanted, and they just kind of went a different direction. And I'm pretty sure that the reason they didn't invest into making better tracing tools is because they felt the measurement intrusion effect risk was too great. And also there's a huge storage requirement. And back in 1989 to 1992, when a lot of these concepts about how Oracle would be measured kind of got spec'd, the measurement intrusion effect and storage requirement things were just too great for Oracle to cope with. So they went a different direction. And one of the selling points of the alternative that Oracle chose is that it's always on. And a lot of people would probably have objected to leaving tracing turned on all the time. But the measurement intrusion effect of tracing is really not too bad, at least not today. So what would make more people trace? Well, people don't trace now because they don't understand how or why, because Oracle doesn't focus your attention on it. They're afraid, again, the measurement intrusion effect specter raises its head, or because Oracle tools aren't very good. So these are 3 really good reasons for people not to use trace data as much as they could. And what you need to solve those 3 problems really comes down to 2 things. It's better education and better tools. And again, this has been how I've tried to earn a living for the last 20 years or so. So what you should mimic in other databases if you're working with non-Oracle systems, tracing rocks. It's even more useful than you would think. Their procedures for enabling and disabling, they're magic. Copy those. You need tools that can filter, group, and sort. Just mechanically as a language developer, those are the things you need for an application to be able to do. Tracing doesn't have to intrude on performance, and don't pre-filter or pre-aggregate. When you get tempted to do those things, remember Charity's advice of you want to make sure that you don't have to have special like pre-knowledge of what the questions are going to be. When you don't filter and don't pre-aggregate, you have total freedom over filtering and aggregation. And please don't start a tracing tools project without me. I'm so in love with the technology of tracing that I really do hope that if you go down the road of creating a tracing feature in something important, please give me a shout. Here's my contact information. 4 book covers that represent some of my work are there. Once again, I'm Cary Millsap. Feel free to write me anytime you'd like. I want to thank you guys, ladies and gentlemen, for the opportunity again to speak at P99 CONF. It was a lot of fun. Thank you.